In this video, we're going to have a look at the difference between terminating and non-terminating decimals. Now, the word terminating means to end, to stop. So a terminating decimal is simply a decimal that stops after a certain number of decimal places. So if I have 3.1467, that's a terminating decimal. 2.00000001 is a terminating decimal. 2.4 is a terminating decimal. All of these decimals stop after a certain number of places, so they're terminating. Non-terminating decimals, however, don't stop. There are two different kinds of non-terminating decimals. Ones that have a sequence of digits that repeat, like for example 0.3333 ellipsis, or a bunch of digits that repeat 0.123 123 123 123 ellipsis, or they might start randomly, so 3 6 1 2, and then start repeating 387 387 387 ellipsis, and so on. So all of these decimals go on forever, and so they're called non-terminating decimals. You've also got decimal numbers that don't repeat, like pi, for example, which starts off with 3.14159 ellipsis, and so on. It goes on forever, but there's no particular pattern to the decimal places after the decimal point, so it goes on forever. So all of these are non-terminating, and the first bunch I'm going to talk about are recurring or repeating decimals. So I think that, strictly speaking, recurring decimals are decimals where, be good if I could spell, are decimals where there is just one digit that repeats, whereas repeating decimals have a sequence of digits. That means, two or more digits that repeat over and over and over again. Recurring or repeating decimals, one really critical thing about them, all of them can be expressed as a fraction. Okay, so they can be written as a fraction. This can actually be proven. We're not going to do that, although in grade 9 advanced maths methods you do learn. So all of them can be written as a fraction, and vice versa. There are a bunch of fractions, not all fractions, but some fractions can be written as a decimal that recurs. So for example, 1/3, if I wrote that as a decimal, would be 0.333, and so on. Now, it's quite tedious to write recurring or repeating decimals with that repeated digit with the dots after it all the time with the ellipsis. So there's a convention that we follow. If it's a single digit that repeats, we write the digit and then we put a little dot up near the digit. It can either be over the digit or to the side of the digit like I do, and that little dot means that it's that digit that repeats. So if I have 0.1618888 ellipsis, then I could write that as 0. I have to write the first bit in, 61, and then I put the 8, which is the first digit that repeats or recurs, and then that dot there shows that the 8 goes on forever. That's how I would read that. And I would say that's 0.161, 8 recurring. And then we have digits that have sequences. So for example, it doesn't always have to be 0. So let's make it 3.213131313 ellipsis. So I write the bit that doesn't repeat first. Sorry, my 3's are always coming out a bit dodgy there, but you get the idea, I hope. 2, and then it's the 1 3 that repeats. So 1 3, and then I put a bar over the digits that are repeating. So the 1 3 repeats. So the bar says start at 1 and end in 3. Now there is an alternative way of writing that, which you'll see in some textbooks and so on. 3.2, and then they'll put a dot over the first one and a dot over the last one. But I don't encourage that one because I think it can be a bit, not confusing, but you might actually forget to see the first dot. You might not see that first dot, and then you think it's just the last digit that's repeating instead of the sequence. One more example. it could be something like 2.1084 ellipsis. So again, it's 1084, that's repeating. So I'd write in 1084 and I put a bar over it, like so. Okay, so that's basically how we deal with recurring and repeating decimals. Now, if it's a non-terminating decimal that doesn't have a pattern to the digits, like pi is an example of that. So pi, which equals 3.14159, and then keeps on going forever, then there's nothing we can do. We just write out the first number of digits, however many we think we might need, with an ellipsis at the end to say it goes on forever, and then we leave it at that. There's nothing else to do. So these are non-terminating decimals, and that's how we treat them. Nothing else we can do. Okay, that's it for terminating and non-terminating decimals.